Good morning, everybody. How are you? Jim DePalma here, and welcome to our winter webinar series. This is session number 6, and we have been following our low temperature heat pump type of seminars since the beginning. With me today in the background is Christiane Levine. She's running our webinar here in Wells, Darby. Mr. Rob Clemens is also backing me up. Yeah, he's just annoying.
You're not supposed to say that.
Yeah, I could say that. He's going to be watching the questions for us. And really the featured presentation or the featured presenter is Mr. Dave Holdorf from Taco. If you guys don't know him, you should. If you're not on Taco After Dark, you should be. Dave is one of the best trainers, very knowledgeable guy, great guy, good friend of mine, and a great mentor. He's taught me a tremendous amount.
Well,
And
now
today
you
we're
just
talking about
raised
Taco
the
System M.
expectations of everybody here.
I'm
All right?
sorry?
You just raised the expectations of everybody that just joined us right now, and it's going to be really hard to live up to that now.
Oh, you could do it. You always shine there. Hence, my favorite nickname for you, you know what it is? Should I tell everybody or just not? You always shine. You're sunshine, man. So, just some housekeeping. If you're new to the webinar series, on your screen, you should see some hash marks, which enables you to expand the screen, make the screen smaller. So as we start the presentation, you guys can make it as big as you can. So you can see it. You can make us smaller. Please type in any and all questions. Questions are great. This is how we know we're engaged with you and we can answer anything that you're thinking about. And also just let us know if you're signed in and there's a group of you watching in one location. That is important to us. Those numbers are important to us. And if you can designate one person to be that person who's typing in the questions, all right, that would be really good for us. So today we're here to talk about air to water heat pumps. So I don't know if everybody's been paying attention out there, but when our president, whether you like him or not, mentions the word heat pump, it's here, it's now, it's happening. And if you're a wethead, you really need to be involved with this. This is important. So a lot of our webinars so far have been on low temperature systems, and they've been on heat pumps, and they've been air to air. We have some other manufacturers who have air to water, and Taco is bringing their product to market, their air to water System M, and that's what we're talking about today. So Dave, whenever you're ready to start, as you guys say, the con is yours. I'm not going to be able to hear him. What is that?
The sound is weird now.
Is he sharing a screen? Because I haven't seen anything up there. There we go.
Yeah, there it is. However, I still can't hear him.
I know, me neither.
Dave, your sound went is off. No, it's coming in like musically, like you're not speaking.
Yeah, we are having a technical issue here, everybody. We are having a technical issue. Just be patient, please.
can't go up to the
I know, I don't know what to do.
Are you able to speak to the
I can, but I would want his information, yeah.
Brian Lebo from Indianapolis says it's got a good beat, but I can't dance to it.
Yeah, I know. It does sound quite interesting.
Yeah, Dave, every time you speak, it's just like music notes.
Holy cow, this is crazy. Yes, Alvin and the Chipmunks. Oh,
Yeah, we got 3 people saying that he should log out and log back in.
Now he's frozen.
He might have done so. He might have been watching.
Doing.
Yeah.
stop. Stop, please.
Okay, there.
There we go.
Ah, there we go.
Okay.
I heard something.
Yeah, you're good now. Can you hear us?
Woo!
Are we there?
Yeah.
Ah, there we go.
Dave, you hear us?
I'm hearing a little bit. It's very, very low.
What are we playing?
All right.
Jim, see if he can hear you.
Dave, you can hear me? A
A little bit.
little bit?
We're able to hear you.
Can you hear me?
Can you tell him yes?
Nothing yet.
Jim.
Yeah, we can hear you.
You got me. Okay. I don't have a lot of volume for whatever reason. Volume's really low on your end, but if everybody can hear me, then I guess we can get started again.
Yeah, just turn your PowerPoint to presentation mode. There you go.
And Chris, can you turn your volume up?
I get you as a whisper.
Ah, there you are.
You can hear me now. All right.
I can hear you now.
All right. I barely hear you, but hopefully everybody can hear me out there. All right. So if you can hear me and you can see the screen, quickly type that into the question section there just to make sure that this experience is everything that you expect today. So
We're
how's
good.
it sound so far, Jimmy? Everybody's typing in?
Yep,
Yep,
we're good.
Everybody's good.
All
See
right.
here.
All right.
They like the beat. We're ready to go. Thanks for
Okay.
hanging
All
in,
right.
everybody.
All right. All right. So let's get this party started now. It doesn't have any weird noise anymore. Everything's good?
No, you look funny, but that's okay.
All right. All right. Let me get this, move this over here so I can see you still as we get this going. All right, so System M. So this is a system that we've been working on for almost 10 years at TACO. So we started thinking about doing some sort of air to water heat pump system for about 10 years. And so we finally introduced this last year to the system. The product is out and available for everybody. So what is System M? Like we said, it's a high efficient air to water heat pump that we are doing heating, we're doing cooling, and we're doing domestic hot water all in one system. All right, one package. Now a lot of people ask me right around here, why did we call it System M and not like System T for TACO? Well, the reason is actually M stands for milestone. because this is something really different coming out of Taco. If you know Taco and you know what we've been making and what we do for the last 102 years, we've been in the arena of moving water, all right? And, you know, everything around the boiler system or your low temperature hydronic system, we're involved in, all right? The only thing that we don't do is make the heat emitters, and we don't make it where the heat comes from. So this is a device now that we are getting the heat from. So we are in the heat generation department now, so to speak, right? And now we are, so it was a milestone for us. So that's where the name System M comes from, just so you're curious about it, about that. So as we, you know, like I said before, we've been doing this for over 100 years. Right here, this is Cranston, Rhode Island. This is our headquarters, our global headquarters. This is where I am right now. I've got a training class going on later this morning. So I'm actually in the hotel room. I'm not at the factory at the moment, but I will be heading over there soon. If you haven't been to Taco, please come by and take a look at us. Tours are always open, and you just make sure you get a phone call before you show up at Taco, and make sure I'm there. Make sure I'm there, right? So we're that family-owned company, you know, around for 102 years, and third generation is running the company, and we have the fourth generation actively working there, right? So when we got involved in System M and started developing it, now obviously we're not going to build and design a heat pump, right? There's a lot of smart people out there that are already doing that. So we needed to partner with somebody. And we partnered with a company called Glenn Dimplex. In case you're curious, Glenn Dimplex is not a person. That's not his name, all right? It is actually the name of the company. And actually, the Glenn Company was founded in Ireland in 1973. And what they did, what Dimplex, what Glenn Company did was they were involved in electric heating elements and heat emitters over in Europe. So they were one of the largest companies out there making electric style heating equipment. And then they went ahead and purchased a company called Dimplex. And Dimplex was now doing kind of the same thing, but also doing heat pumps. And the two companies blended together to form the name Glenn Dimplex. And they're one of the largest air-to-water heat pump manufacturers right now over in Europe. And the partnership with us is able to bring their product and their designs over to here. And we specifically have designed something together that we're calling System M. So, but Dimplex is an amazing company out there. So you may not know the name, you may not see it, but they do supply heat pumps for a lot of manufacturers worldwide. Like, for example, some of the names that we know here, as in Bosch and Brederis, Wiesmann, and Weishaupt, where they are supplying heat pumps into that market that way. All right. And one of the things that we worked with them for the last 10 years was having this German engineered, German built piece of equipment. So we're not building the heat pump itself over in Cranston, Rhode Island, but we are designing and building the hydro box, which we will talk about today. All right. Now, Jimmy, if there is any questions and as we go along, don't save questions for the end. Please ask them. I can't hear you well, so you may have to just wave your hands to interrupt me a little bit. I can see on the side of the screen over here, Jimmy. So, so let's take a look at it. So let's take a look at the Dimplex unit that is designed for us here at Taco. So this is our outdoor unit. All right, this is the heat pump itself. And here's that look behind it. And these are a couple of projects that I went and visited. This one is actually up in Toronto. And this project here, the second one on the right-hand side of your screen, this is in Connecticut. So, and then with this one here in the middle is out of Vermont. So yes, can we use air to water heat pumps in a cold climate? I would say yes. All right. And Jimmy and I have talked about this. It's all about the design. All right. You have to make sure you have an accurate heat loss performed. All right. And it's sometimes, I've done a lot of designs in my life, right? And Jimmy has too. We've done a lot of radiant projects over the years. And sometimes, when somebody asked me to do a design, it looked like it was the sketch of the house was on a napkin drawn with a crayon, and then it was shoved in your pocket and then put through a fax machine and then sent to us and say, hey, can you give me an accurate materials list? All right. Well, you're not going to want to do that when it comes to sizing up and selecting a heat pump here, right? We want to make sure we have an accurate design, and, so we can get to all the areas across the country itself. And it's going to work as long as we do the math, right? So let's take a look at the heat pump itself in details. All right. First off, we have this huge heat exchanger on the outside. All right. And from the pictures before, you don't see that side. That is the side up against the house and the airflow coming in this way. All right. And, but it's huge channels, huge spacing in between. So you get a nice, good airflow in there. And we also try to make it as big as possible so we can minimize any freeze ups and frosting on there, right? So we can keep that defrost cycle down low. We don't have to run too many times. Now here is our fan, nice, big, huge variable speed fan. And the blades and the whole cabinet is designed a little bit different. So let me go back one slide a second. I want to show you that, one, you don't see the fan from the outside. All right, and it was designed this way on purpose. What you have is a side discharge. So the two sides is where the discharge of the air comes out. So you don't see it coming straight through there. And it's a lot different than a lot of other units out there, because one of the things that the Dimplex people have found is if you see something moving, it is assumed it makes noise. And when we start looking at where heat pumps have to be and installed in a lot of projects out there, we don't want it to make a lot of noise. And you might have a noise ordinance in your town. And believe it or not, homeowners would complain saying, oh, that fan is spinning, it's making a lot of noise, and it wasn't even powered up yet. So we did the side discharge, and yes.
Oh, no. Well, I didn't want you to stop, but
Okay.
do you have an idea of decibels? Because we are getting questions about, the volume on the fan.
Decibels, I believe, at full speed is, oh boy, I just ran a blank on it. I think it was 54 decibels.
Okay.
Whisper.
All right,
So
which
that's a whisper,
is
so-
about the noise level of a refrigerator.
Right. So really, when you're in front of us and we're doing a presentation, that's less than our speaking voice. So this is a quiet system, very quiet.
All righty. So let's continue on. All right. I'm just wondering why I can't hear you that well. All right. So that's where we have the fan design behind it, right? Right on one side of the outdoor unit, we have our control box, everything accessible from one side. Not a lot of wiring going in. We'll go through the wiring details there. Okay. And now we have our compressor, and we are looking at a typical Copeland scroll compressor, inverter driven there. So it will be a variable speed compressor. And here we have our plate heat exchanger. So we have a flat plate heat exchanger here, where now we will have fluid in here. And if you can use straight water, great, if you don't have to worry about it in a freezing condition. Or you may have to put a little bit of glycol into the system, and try not to put too much in, obviously, right? Not that that's horrible, but I know a lot of people don't want to put too much glycol in there because this is sitting outside. All right, so you have a small amount that will be outside, and you see your connections that are going to tie to the indoor unit. So this is a complete monoblock design. All right, everything is self-contained in the heat pump itself, so we don't have any refrigerant going back and forth between the house. It is already a pre-charged system. You don't necessarily have to have a refrigeration license to work on this and install it. We are looking at a standard plumbing system here, where you're tying in two pipes that are going to tie into the indoor unit. Okay.
So Dave,
if you are looking at glycol, the one thing to remember about glycol, when you're reading the charts and putting your concentration in, and if you're looking to protect to, say, a 0 degree temperature. Now remember, that 0 degrees that you're reading from the glycol manufacturer is fluid temperature, not air temperature. All right, so I find a lot of times we way over glycol a lot of projects out there. We just, it's 0. We got to make sure it's going to protect to 0. Now that would be the air, the fluid temperature itself. And what happens if you don't have, what happens if it gets to -1 degree? All right, does everything just freeze up as a solid block? No, what you have now is the capabilities, or the ability for crystals to form in the water itself, not necessarily freeze, not necessarily even get slushy just yet. So just be careful on how much glycol you do add to systems themselves. They don't need a lot. Now let's go into detail on what the heat pump has itself. All right, so as we look at what's inside, what's behind the covers that you can't see is the system control unit. all right, which is communicating to the refrigeration circuit manager, which is in the inside portion of the system, right? And we have the power supply transformer in here. We've got a bunch of fuses to help protect it for any spikes or anything like that may happen, and the drive board that's there. So there's a lot going on under the cover that you can't see outside of what I was showing you before, right? The biggest thing is the computer communicating back and forth to figure out what to do, meaning what speed to run at, how fast am I going to run, the fan itself, run the compressor. So what we've tried to do with here is the system is to modulate the world. All right, everything that can be a variable speed or change is going to do that in the heat pump itself and also indoors at the hydro box. Okay. So as we go to the hydro, yes, sir.
Yes, sir.
Yeah, Dave, I got a quick question for you. So it says there's an inverter drive board on board this unit. Does that mean we have an ECM fan motor, or is that variable speed AC voltage, and the compressor as well? Is that DC driven?
I think I heard, is the fan itself an ECM motor? Yes, it is.
Okay.
And is the compressor DC driven also?
The compressor is variable. Yes, I'm not sure on the power that it takes. I haven't done the wiring on it. Is that the question?
Well, yeah, we want to know if it was DC driven or we know it's variable speed. We just want to know if it was DC or not.
Oh, that I don't have off the top of my head. I'm sorry for that.
Okay, no problem.
And sorry, I was trying to change the volume so I can hear you guys, but I got the volume cranked all the way up at the moment. So let's get this back to presentation mode. All right, let's take a look at the hydro box. Now, the hydro box is obviously what we've built at TICO, and these are built in Rhode Island, in Cranston, where we designed and built everything here. So the hydro box has everything that you're going to need to successfully install and operate a heating and cooling and domestic hot water system, all contained in one box. All right, you've got everything that you need installed, except for, say, one circulator that you're going to use to pump fluids out to your house to cool and stuff like that, right? So let me go in detail. Let's take a look and see what's inside. Well, one, we've got 6 shutoff valves that are located right in the top and in the back control board. And those shutoff valves, these are your pipes that are going to feed out to everything, okay? And we'll go into details on what those pipes look like. So we've got shutoff valve isolation on the inside. We have 2 0034E circulators. So the 0034E is one of our ECM variable speed circulators. And the reason why we use the 0034 in there is because these circulators have a 0 to 10 input, which means from the control system, we're going to give a signal to the circulator to become variable speed. And it's getting that system control on how fast it needs to run. And so the 0034 is our first ECM circulator that has that 0 to 10 input to the circulators. So we denote we call them M16 and M18. So the M16 circulator is dedicated to pump between the hydro box and the heat pump itself. And then the M18 circulator, which is on the left-hand side of the box itself that you can see, this is going to our indirect tank for our domestic hot water. All right, so we call that M16 and M18. That has to deal with the software, so that's just the designation that we give it. Now, here's all of our wiring. So we do have our line voltage wiring, and our low voltage wiring is also included right here with our outdoor sensor. And we also have a Cat5 connection to put the system online. All right, so we do want to have this entire system placed on. It doesn't have Wi-Fi. We're looking at a hard wire Cat5 tie-in directly to it. We have also installed a number 30 expansion tank. All right, so for our hydronic system, as the water's heating up and cooling down, we have an expansion tank installed. We do have our 4900 air separators installed. We do have a relief valve built in. We have our high vent inside also for other areas to get the air out of our system. And we also have a buffer tank. We have a 30-gallon buffer tank with an immersion heater built in to the buffer tank itself. All right, so this is what we're charging up. The heat pump is going to charge up the buffer tank, and then our hydronic system is going to draw from that for heating and cooling the house. And because we never know where this is going to go inside somebody's home, the entire base is a drip pan, and we have a drain and a tap for that. So this way we can safely, if you have any condensation that may occur from any when you're doing cooling mode itself, we do have everything insulated. It is wired, sensors, all the controls are built in. So this is what's inside that we can see. In detail, what you can't see in the hydro box, all right, is again that refrigeration circuit manager, all right, so which is communicating to the heat pump itself. So that computer, which is right behind here, right on that front cover panel, right below the touchscreen. We do have our power supply transformer. We have what we call the UHI, the user heat pump interface. That is the touchscreen right here, so you can program and set up the device itself. And there is a computer back in here. We got a Raspberry Pi system set up that has a Bluetooth control, a micro SD, and also your internet connectivity behind it. So there's a lot going on in the hydro box itself, not even thinking about all the wiring that's involved. So when we looked at this, designing this hydro box, what we're trying to do here is to make sure that you've got everything set up in here. We've got easy changeover in the seasons. All right, so there's nothing that needs to be done other than just programming temperatures on where do you want it to be heating mode and where do you want it to be in cooling mode based upon your outside air temperature. So you don't have to go ahead and change any valves, open and close here and there as the seasons change. It's all integrated into one box. And we have estimated and worked with a few contractors out there where they have built their own boiler rooms with a air to water heat pump before, and you're saving at least 2.5 to 3 days of time of building this mechanical room and making sure that you didn't forget one thing, right? Mm-hmm. One little wire, one little sensor, anything like that is all done. Yes, sir.
All right. So just to clarify, everything in the hydro box that you guys put together, nothing exotic, everything that a plumbing contractor has seen, has played with before, right? Nothing there should be intimidating to anybody. All right, correct?
That is correct. So anything that is that needs to be serviced is nothing extraordinary. Correct. Right. Now, what is extraordinary in the hydro box is also what we call our oh boy, I just forgot the name. I had this name in my head all day today. I wanted to make sure I said it. It's a dual differential pressureless manifold. All right. Wow. So meaning all the hydraulics. All right, there's certain design that needs to be done in order to work effectively between a buffer tank and the heat pump itself, and to deliver the energy out to the house itself, is all designed in here. So, we not an easy thing to design and build and put on a wall. All right, and just think about how much mechanical space you would need to get that pressureless dual differential pressureless manifold, as we like to call it, in there. It's a very extensive calculations that were done in order to make this work for every project out there. So yes.
So Dave, I know we're going to get to it. We're going to get into how the unit really operates, incorporating it, sensing outdoor temperature or outdoor reset. And we're getting a lot of questions. Just to prime you up, we're getting a lot of questions of efficiencies. How's the unit going to be operating at different outdoor temperatures? And how long does it take when we're switching back and forth from either heating and or cooling? So just to let you know that those questions are piling in here. So.
Okay, so let me talk about the difference between the heating and cooling. So when you are looking at an air to water heat pump in here, when's the unit most efficient?
When it's off.
When it's off, right? And that is the goal, right? We don't want to be running tremendous amount of power and electricity all the time, right? So what you want to do when you are setting up the hydro box is that you choose a outside air temperature that whatever it is below that is going to be in heating mode. Then you set up an outside air temperature on what it's going to be for cooling mode. It's not the same temperature. All right. We think it might be, but usually it's not. When we think about the spring and the fall, usually we've got a buffer of time where you don't have anything running, and it's a beautiful time of the year, right? So where we're not using any fuel to heat our homes, and we're not running the air conditioning to cool the home, it's just a perfect time of the year, right? And that could be a several degree temperature difference, right? And that's what we're programming in there. So we don't want to go from heating to cooling, all right, in the same day, because now the whole idea behind the hydro box is storing that energy in that 30-gallon buffer tank. So you don't want to chill that water down and then in 20 minutes, let's go ahead and heat it, because it takes a tremendous amount of energy now to warm that water back up again. So there will be that time in between where the unit's off, right? And we're looking at maybe an 8 or 10 degree difference in outside air temperature. Now, one of the things we can do with this, for example, we do get those, cold morning. We get that. We get a cold morning where this may have turned into a heating design, and we got hot water sitting in the tank itself, and it warms up tremendously during the day. Or, like what's coming up, some holidays are coming up real soon in the spring, and you have everybody over the house, and it starts to get nice and hot, and you got to cool it down. Opening the windows and turning the fans on is not doing it. There is a forced cooling changeover. So you can use a thermostat in the house to force this to go into cooling mode. All right, so there is an input to do that. So you can force it over into the cooling design. But the heating is based upon your outside air temperature. Hopefully that answers your question there. And performance-wise, I've got a couple of charts that I'll show you in a couple minutes. All right, I think it's coming up rather quickly. So let's talk about installing and what's needed to install System M, right? So when we look between the hydro box and the heat pump itself, just so you have a couple of dimensions out there, all the panels are accessible. All the outside panels do come off, so you got to leave some room. And we're looking at about 1.5 feet on either side. So you can get in there. I'd rather see more like 3 feet. All right, on the sides, to making sure you got proper airflow. Don't put bushes in the way. And this thing does have some pounds to it, right? We're looking at 385 pounds, and it's quite tall. All right, your hydro box indoors is weighing a lot more. All right, we got a lot more copper in here now. So we're looking at about 415 pounds for the hydro box inside. So making sure that they're on proper slabs, supports, and things like that. Heavy gauge covers on the outside of it that are also powder coated. All right, so it's a nice heavy cover on there. So even on the outdoor unit in some of our areas, especially where we are here in the New York, New Jersey market, we don't have tremendous amounts of snow. All right, but if you do this, everything is pretty much high up on here. All right, the low part is relatively empty except for your compressor and things like that. So you can handle some load of snow leaning up against the cabinet. Now you get this thing out in Minnesota and Montana, where we've got a very large snow load. You might have to build an elevated stand for this. You don't want that much snow covering it up. Across the top of the hydro box, these are our connections. So remember from when I was showing you the picture on the inside, you've got a couple of isolation valves. That's right below here. So these are 1-inch pipe threads here, and you have 6 connections. That's all you need. You've got supply and return from the right-hand side going to your heat pump. On the left-hand side, you have your DHW supply and return. That's going to my indirect tank, not the supply to the house. All right. And then in the middle is our heating and cooling circuit. All right. So however we're doing the heating and cooling, those 2 pipes will go off and go to the heating equipment itself for the house. However, and we'll show you some piping diagrams that maybe if you're zone pumps or zone valves, that you're designing a system. So here is a quick example of how we would lay this out. All right, right now I'm showing heating and cooling being done by a 2-pipe air handler. All right, that can handle chilled water and hot water to do it. And that is going to be controlled by what we call circulator M13. M13 is a field supplied circulator. It's not going to be with the hydro box. So this is the choice based upon the equipment that is being used to heat and cool a home. So M13, if you can get a 0 to 10 circulator there, like the 0034, or even some of our other and older standard AC circulators that are called the VV models, that now we can have System M control the speed of that circulator too. If not, it can just be a standard on-off circulator. And then you have your you have your DHW indirect tank that you see here, and then your 2 pipes going out to the heat pump. All right, now we prefer to have that pipe come from underneath through the support, the slab that the heat pump is sitting on, insulated pipe if you can. But as you saw in several pictures, you can go through the sidewall itself and tie into the side of the heat pump that way. But we do prefer to have that underneath come through, so you got a nice straight connections feeding into it, and as much as possible, the pipe's underground.
Is that you mentioned straight pipe? Is that because you have some flow considerations you want to be aware of?
I'm sorry, what was that?
You mentioned that you want to keep the pipe straight. Is there an issue with, or something we want to be concerned about with flow considerations?
No, not at all. Just if it's just as minimal exposed outside.
Oh, all right, fine.
So if you keep it straight, it's just feeding right into those 2 connections in the heat pump itself. So it's not flow considerations. It's just, yeah, try to keep as minimal exposed outside, right?
Okay.
So yeah, and here's the details on it, right? So your distance between the 2 units is that we're looking at about 75 feet away if you're looking at 1-inch pipe, whether this is going to be copper pipe or even some pre-insulated PEX pipe. All right, so I know Wales Darby gets involved, some pre-insulated pipe, and it even comes in 1 tube that's completely insulated. All right, you got 2 1-inch pipes in there, if I remember correctly from my old days, right, Jimmy?
Yeah.
Okay. All right. Just wanted to make sure it's still there, right?
Still there, babe.
I haven't looked in the catalog at Uponor for a while, so so if you need to go further away, then we upsize to 1.25 inch, and you can get yourself about 100 to 110 feet. Just making sure that we do the calculations of the flow rate that the 0034 can supply. We're looking at a design of around 8 gallons a minute flow. So use that to do your head loss calculations to make sure the distance is going to work for your application. But again, 75 feet away is a lot of distance. All right. So, between the 2 units. As we look at the indirect tank, so the System M comes as one part number where you get the hydro box and the heat pump together. All right. And they have to be together. We marry the software to each other and stuff like that. But now the indirect tank, that is a separate item altogether. And what we're looking for out of an indirect tank is something nice and large. All right. We want to see 1-inch pipe minimum, prefer 1.25 inches between the 2 of them because we have a really high flow rate. So 1.25 inches, 1.5 inch pipe is great in there. Again, that 0034 in there, but now we're looking at around 28 gallons a minute that we want to flow back and forth between the heat pump, hydro box, and the DHW tank, which means our indirect tank needs to be a high capacity indirect. We want to have a very large surface area for the heat exchanger surface. So not just any standard indirect tank is wanted here. We want to see that high surface area. I think, if I remember correctly, around 30 to 35 square feet of surface area in there. So you're looking at those low temperature indirect tanks in order to give you enough. And I would say even most of the time, as much volume as you can get, like an 85-gallon indirect tank was great. All right, hopefully and also you want to have possibly one that has an electrical element. Now we have one, we made one available to you. So it is a separate part number outside of the of System M itself that does have that large surface area with the electrical element for that emergency backup for the element to kick on to give enough domestic hot water in the home itself.
Hey, Dave.
Now, let's take a look at some of the piping going in between, right? So now this is all the field supplied piping and size that pipe based upon the heat loss and the heat gain that you need. So what we're looking for here is probably no larger than 1 inch that you're going to need. We're not going to see a huge flow rate going on out there. Now, this is a simple design with our example here with the air handler and one circulator being supplied. But you can go with, zone valves. You can do multiple pumps on the system. That's your choice on how you want to do it, like we have done hydronics forever, right? That's the flexibility and that's the freedom that we see out of a hydronic system, right? We have a lot of flexibility on, you want to do some radiant floors and you want to do an air handler also. So radiant floor for the first floors and air handler for the second floor, make it 2 zones that way. You want to do zone valves or actuators on your manifolds for a radiant floor, perfect, right? So we've got a lot of flexibility there. So, for example, let's take a look at your, let's call zone valve 1 is going to be the cooling going to your air handler. Zone valve 2, 3, and 4 is going to be, say, a low temperature panel radiators. All right, so now you've got low temperature panel rads that have a great heat output at, say, 125, 130 degrees. Now, the one thing we didn't do on the indoor unit is put in any magnetic dirt separation. So if you want to, add that on the return side, feeding back in to make sure we collect any debris that might be in our system as the install went along. Now, I get this question all the time, and we'll come up to the performance and the outputs of the units real soon. But hey, you know what? I still like to have the safety, and I've got a boiler already sitting in my house. I don't want to have to toss that boiler. So how about we use that for that supplemental when we get to those really cold days? And for those of us here, local in New York and New Jersey, we remember 2 distinct days this season already, right? It was Christmas Eve, where we dropped almost 40 degrees in several hours. And for those of you that were working in that, I applaud you, because that was just in some insane days. I mean, my house wasn't even keeping up because it just got so cold so fast. I have a radiant slab, so the slab, all of a sudden, it was 52 degrees during the day and 9 at night. And my radiant slab said, "Excuse me, what? What do you want to do now?" "Oh, you want to heat the house? Well, first you got to wait for the concrete to get warm. So we're going to slowly heat that up." And so, yeah, my house dropped a few degrees. My wife wasn't happy, but it warmed up eventually. So you've got that boiler in the background. So here's a suggested piping diagram. There is no direct communication between the 2 units themselves. So we do have some suggestions on how to wire this in. So the boiler will all of a sudden kick on and supply the heating out to the house, and also can supply the DHW. So it's just the addition of a couple of zone valves that we can make that work. Yes, sir.
We have an amazing amount of questions. Some of them are really pretty cool. You're getting to a lot of them right now. Let me say, I'm sorry. Gosh, I just missed what I wanted to ask you. It's gonna come to the control, and I know that's coming up. But if we have the ability to program in the control 2 to 4 hours as not to overheat a thermal mass on days that we experience a 40-degree rise, especially in passive homes. I don't know if that's possible.
Try to repeat that again. What are we trying to do?
So the question came in from this gentleman, Jeff. It's a really good question. Let me see. Do we have
It's just
on the
that I can hear
hydronic?
you. That's all.
All right. So on the hydronic side, does the program turn off heating based on 2 to 4 hours out as not to overheat the thermal mass on days that we experience a 40-degree rise, especially in a passive home design?
Okay, I got you. Yep. So what the hydro box and the heat pump itself are doing, they're not communicating to the house. We don't know the temperatures. We don't know if the heat zones are on. We don't know if they're off. The only way we know they're on or off is when M13 circulator turns on and we start seeing temperature change inside the hydro box. All right, so the whole idea behind the hydro box and the heat pump is that, one, we have an outdoor sensor tied in, and we have, if depending on how you program the system, meaning, do I want to have a variable water temperature stored in the tank, or do I want a set point temperature in the tank? And it's always going to be trying to charge the tank. So it's not like we see today with boilers, which means when there's a call for heat, the circulator turns on and the boiler turns on. That's not how we're doing this here. The heat pump is only designed to turn on when there's temperature demand needed in the tank itself, in the storage tank, in our buffer tank there. So it's going to have a target temperature that it's going to try to get to and just slowly keep on charging that tank. Then M13 is turned on and off by your thermostats in the house. I hope that makes sense, right? So
Yeah.
there's always going to be some sort of charge in here.
So following up based on this design here, the question came in, I'm in cooling mode, and then there's a domestic hot water draw. How does the system handle that?
Okay, so that's the idea behind the buffer tank here too, right? So the buffer tank, when the indirect tank needs to be turned on, we have that 30 gallons of chilled water that we can draw off of, and the internal piping with the dual differential pressureless manifold. There we go. I got it again. All right, that the when the heat pump is running in domestic hot water mode, it bypasses the buffer tank completely. And at this point too, don't remember that in the summertime, there's a tremendous amount of energy in that air outside. So it's going to bypass it rather quickly, and we're going to get that heat to the indirect tank really fast. All right. And we'll be able to draw the house off of that 30-gallon buffer tank inside. And then it will, if the temperature is slowly rising in that tank itself, then it's going to, now it starts making decisions. Always priority is DHW first. Now, here's also the unique thing with the Hydro Box and mostly the interface and the software. You can program when to recharge the buffer tank. 85 gallons is a lot of water. It's a lot of water, and it's a very insulated tank itself. We're looking at maybe a half a degree, about a third of a degree an hour that we might lose just sitting there. So it takes a real, so we've got a very insulated tank here. And so you can program when to make domestic hot water. For example, at nighttime, recharge the tank. So it doesn't turn on at all during the day, because we all know most people use water at specific times, when you're drawing off your tank. So it might only be in a couple hours in the morning, right? When we're all taking showers, there's a little bit of draw maybe in the afternoons when we're home, or in the evening, but you can tell it to run at, say, 2 in the morning to recharge the indirect tank, so it's available for you when you first wake up, because you've got a lot of energy in that outside air and your cooling demand has dropped. All right, hopefully that makes sense in there. Any other questions there, Jim?
Oh, we got a pile of them, but that made a lot of sense. Everybody's going to have to realize how we program this up to take advantage of off
Right.
time.
Yeah, that's
right?
very flexible in the control software, correct. Yep.
Right. Bank the energy where we need it in the off time and be prepared for when we're awake and then, going about our day. Somebody asked here if they can have 2 indirect tanks if there's a really high domestic demand.
Oh boy. I guess that would depend upon how you design it, but actually I can show you another piping diagram that's coming up on the next screen. Right. So here, I would say, rather than go to 2 tanks, maybe you're looking at the boiler that you can supplement that indirect demand with, like we show here, or just go larger. I would probably rather go larger in the tank rather than putting in 2, but not impossible. We could, maybe control that with a couple of zone valves, charge one tank, then charge the other. So again, that's the beauty behind hydronics, right? It's not going to have direct communication. Maybe only one of those tanks is going to be your, with the electric element that's being controlled by the Hydro Box and the software, and the second one wouldn't have an element. So there's a lot of flexibility that we can do with that.
Okay.
Or, for example, I know Jimmy has talked about this before. All right, you throw your electric boiler in line with this. So, for example, you could drop an electric boiler right here that is in line with the heat pump itself to supplement your buffer tank. All right, and or supplement your DHW tank. So it can be in line here, and this would be controlled obviously by outside mechanisms to turn on the electric boiler to do that. So as we start thinking of this low temperature and beneficial electrification, instead of having that fossil fuel boiler, then we come over here to an electric boiler to give you the extra backup that you're looking for.
Right.
So this is actually what we have installed in the home in Toronto. In Toronto, they do a lot of electric water heaters and electric boilers that are usually rented by the utility. And so my buddy Mike up there in Toronto has this installed in his home, and he thought he was going to need it because he's got 4 little kids at home, and when it comes to bath time and things like that, and he figured, yeah, I'm going to need it to supplement my indirect tank. Well, he's had it in his home for at least 4 years now, and it hasn't turned on once. Hasn't turned on once. He has not needed it with 4 little kids. He's had plenty of domestic hot water coming out of an 85-gallon indirect tank with 4 little kids. All right.
Okay.
So, but yeah, they just get Navy showers more or less, right? They just hose them down real fast and move on. You know, it's an assembly line. I'm joking.
I don't know if everybody knows what a Navy shower is, but
Yeah. Real fast, turn it on and off quickly, stand there cold. Yeah, right. Yep. All right. Wiring up system M. All right, let's go through real fast on the what demands are needed. All right, we take a look at the 120 volt. All right, not a large amount of the 120 volt is needed, but we do need to power up the computer and input on the hydro box itself. So we're looking at 120 volt, 15 amp circuit. That same exact circuit we need to send over to the heat pump itself. All right, we want it to be on the same circuit. And the reason for that is if you are doing any service on any one of the units and you turn the power off, we want both units to shut down at the same time and also both units to turn on at the same time. So it has to be a shared circuit between the two of them on that 120 volt side. And then when you have the 240 volt element in the DHW tank, all right, we're going to supply contactor for the relay to kick that on. So it is 120 volt 240 contactor to turn on the element in the DHW tank because you've got a large element that's in there. So that's it, what we're looking for in that 120 volt power. Now when it comes to 240 volt, all right, we are looking at 240 volt 30 amp going to the heat pump outdoors. All right, so that's on its own breaker. We're going to have a 240 volt 30 amp going to the immersion heater on the indirect tank. And then we're also going to have another 240 volt 30 amp to the buffer tank immersion heater. All right, so the buffer tank inside does have a 30 amp break, 240 volt element in there also for that emergency or when we start getting to those cold days outside. All right, so yes, we are looking at about 90 amps needed. All right, but we're eliminating your fossil fuels here. All right, we are eliminating. So in my experience and a few of the projects that we've worked with so far, we have, you know, that home, you know, a lot of these newer homes, or if you're doing some electrical work, it's going to be a 200 amp service brought into the home. Definitely. Yep. So yeah, that's what we're looking for, our electrical. Yes, sir.
Yeah, we're getting a lot of questions when it comes to power and things of that nature. So, you know, at least the house has to have at least a 200 amp service for this to be viable, correct?
Yes, correct. I would see at least 200 amp service to the home, correct.
Okay. A really cool question that came in, if we were doing radiant cooling, do we have a way of tying in for dehumidification, if I read the question correctly?
No, we are not looking at, again, with the system M does not know the temperature, the humidity, or anything like that inside the home itself. So if you are looking at doing radiant cooling, that would be controls by others. All right, so now what you need to make sure that you have is a thermostat that is going to read humidity in the home and also modulate your water temperature being delivered to the radiant floor or radiant ceiling or radiant panel cooling system itself. So this way you always want to stay at least 2 degrees above dew point so we don't have any condensing in the home. So external dehumidification is going to be needed if you're concerned with condensation occurring inside the home. Now, one of the things about radiant cooling, all right, and Jimmy and I have had some experience with it. It was, I didn't do a tremendous amount of it. My previous life before Takeo, I did work for Uponor, all right. I did do some radiant heating a lot of times, and I did do some radiant cooling, but not a lot of designs. But a radiant cooling system is best installed in the ceiling because that's where the heat is, right? That's where all hot air is. All right. Radiant floor heating is typically better in the floors. All right. So to try to do a radiant floor cooling, you're only going to get a small percentage of the cooling load of the home. All right. So you're going to get maybe 30% that you can cool that load down through the radiant floor. So you're going to still need some sort of cooling system where we'll go with a hydro coil, so to speak, and you can run the cooled chilled water through that. So that can help you remove that humidity. So yes, take advantage of the radiant floor heating and make it cooling, and you've got 30% of it, and you know, without having to turn the air system on. So it can be done It's just, you know, now those floors start to get a little cool and you just got to be aware of that. Not too cold, all right? Because again, we can modulate that water temperature, right? So now hopefully that answered your question. Excellent question. Thank you very much. Anything else or should I move on, Jimmy?
Here's one. This is really pretty cool. So what happens in the dead of winter, and the family has an electric dryer, electric stove, well pump, and a pump to the septic. He's pulling a lot of power, this poor guy.
Uh-huh.
And then he has a system M. So what does he have to be really aware of or be prepared for? I guess his service is going to have to be.
Just make sure you got enough service into the house. If you're running everything electric in the house, and a lot of people want to do that, and that's great, right? That can be a really good system. It's just like anything else. You got to make sure you size it properly.
Yeah.
Got to make sure it's sized properly, like, you know, making sure the heat loss is proper for this project, making sure you pick the right boiler, pick the right circulators, all this other stuff in between. You know, you got to make sure you have enough power brought into the house itself, and the panel is going to be able to handle it. That's really about it, right? You know, yes, this is going to be a large portion of it. Now this, when I show you the 90 amps here, do you think it's pulling 90 amps always?
I think that's the concern. Yeah.
No, this is not pulling 90 amps always, right? So, you know, this, you know, your elements are, we program the system to keep the elements off as long as possible, not on. Just don't imagine the buffer tank immersion heater is going to be on all the time. It is rarely on. It's only under those extreme conditions where we have perfect alignment of the planets, all right, where all of a sudden I need everything you got. All right, so we're not going to have a buffer tank immersion heater and the DHW tank immersion heater on at the same time. That doesn't even happen in the system itself. So, you know, so yeah, you've got some flexibility. We're not going to be pulling all 30 amps, 90 amps at the same time. All right.
Right.
So excellent question. Excellent question.
Yeah. We're getting a lot of questions on output. You know, what are we getting as our coldest water? What are we getting as our highest heating? And I know we're coming up to that. So
yep, it's coming right after this, correct? Yep. And the last connection that we need to have is that we're just running a 2-wire shielded wire. I prefer to have at least several wires involved. You can have a Cat5 in between here, and it's just a communication mod bus between the indoor unit and the outdoor unit. Okay, and that's it. That's it for your wiring. All right, that's it for the wiring that we have going on outside to everything. And then, of course, there's your Ethernet connection going to. There's no Wi-Fi in there. What we do want to have, it's a hard wire. And if the hydro boxes ends up in the garage where you don't have, you know, a Cat5 connection or the routers on the other side of the house, there's an easy way to get things communicating. You can get yourself what they call a wireless bridge. All right. If you're not sure what a wireless bridge is, you know, take a look at it on Amazon. They go for like $30. Basically, it's a Cat5 wire and it's wireless and will connect to the Wi-Fi of the house itself. So you can do that too, very successfully. So, but we just gave you a Cat5, and we prefer the Cat5 more for a hard wire. We don't have to worry about any Wi-Fi communication issues when something's not communicating back and forth. So now let's get into the performance and what this puppy can do, right? So what can we get out of this? Well, here is our charts. All right, so this is what we're taking a look at. And I drew a couple of lines on here. So what we have, the curves is your minimum and maximum, and that is your output that the heat pump itself can do. And a heat pump, and I'm sure Jimmy has talked about this during this whole season and this series, that a heat pump's performance is all based upon outside air temperature. All right, the outside, you're trying to grab energy from air. All right, and the colder the air, the less energy there is available to it. So for example, if we take a look here, and I know it's not that far off in Jimmy's neck of the woods, where we're looking at a 12-degree outside design temperature. So if we take a look at this maximum curve here of the heat pump, we're going to draw out of here about 28,000 BTUs. Now, we're not, and neither is Dimplex, all right, we're not irretrievably stupid. We know we're going to need a little bit more. So the electrical element is what this line gets us up here. All right, so the electric element in the buffer tank, all right, is now going to give us, whoops, sorry about that, is going to get us to almost 50,000 BTU output. All right, So we've got a lot more availability to you to heat the home itself. Now, of course, is every zone calling and every zone set for 70 degrees? Again, perfect alignment to the planets, when we're going to need every last bit of it. Now, I've had plenty of people look at this chart and say, oh my God, that's not going to work in my house. And I said, why? You know, what was your heat load calculation? Well, I don't know, but that just seems low. Okay. And it is imperative that you have a proper heat load and heat gain calculation performed on your home here, to make sure. And I've done a lot of, I've probably done around 10,000 designs in my career. I started doing this 25 years ago, doing radiant designs. And the software that we use is very, very, very forgiving. All right, when we start plugging information in there, it will give us so much fudge in our heat load calculations. It's surprising we're not all diabetic that does heat load calculations. All right. I had to steal that from my buddy JB, right?
Yeah.
So he says that quite often. There's so much fudge thrown into heat load calculations. For example, there was one software that I was using that there is in there, you have to find it, and a lot of them have it, a user-defined adjustable safety factor, which means it just tacks on a percentage at the end. You put all the calculations in there, and there's a lot of people out there that want to have that safety factor calculated in there. And then the other thing that most software does, it gives us an assumption for air changes per hour. And there are assumptions that are done. And when you are looking at installing an air-to-water heat pump, you want to make sure your house is as tight as possible. And to find out what the air changes per hour is done only by a blower door test. You need to have a performance check of the home, and you have to tighten it up. All right. So where we see a lot of these getting installed is in a high performance home. All right. Large insulation values for the walls and ceilings, spray foam. All right. SIP panels, structurally insulated panels being installed, passive design homes. And these projects, we're looking at, we're not looking at, little tiny bungalows at 900 square feet. We're looking at 5,000 square foot homes where this unit works just beautifully. It has to be designed that way. All right. It's not going to be a direct boiler replacement. If you are sitting at the kitchen table trying to design a heating equipment for a homeowner and you see a dust bunny go across the floor and nobody walked in the house, tighten the envelope. So, and this is something that I live by no matter what type of heating equipment you're putting in, right? Envelope over equipment. If you are looking to save energy and trying to put the latest and greatest and modulating everything in there to save energy without changing the home that was built in 1967, all right, your end result is not going to happen. All right, you got to treat the envelope first before the equipment goes in there. So now the question that came up before about the electric element, when does it come on? And that's what this yellow line is. So when you know what your heat loss is of a project, all right, the exact heat loss that you have there, where the two lines intersect on your heat output or whatever your heat demand is of the project, we draw this line down to 70 degrees. And where it crosses the maximum is the outside air temperature that we will program for the electric element to kick on. Doesn't mean it's going to turn on. So what we have, so to speak, is this triangle that we might see the electric element come on. And the way System M looks at when to turn on the electrical element in the buffer tank is going to be, one, based upon runtime. So the heat pump has to run for at least 1 hour straight. Two, it has to be not changing temperature. All right, the temperature that is entering the the buffer tank itself, if the temperature hasn't changed in that 2 hour time period, that 1 hour time period, and it's within 3.4 degrees of the target temperature, then the electric element kicks on. All right, so there's a lot of factors, and we're trying to keep that electric element off. If we are slowly increasing the water temperature in the buffer tank, that means we're creating more heat than is needed in the house itself. Okay, so we try to keep that electric off as much as possible. I hope that makes sense for everybody. Yes, sir.
Yeah, no, that makes complete sense. And I just kind of want to add on to what you were saying before about, the envelope. Going forward, everybody, these systems, we're not just going to take out a boiler and put these systems in and call it a day. There's a lot more education that has to be done to our end users. Upgrading the home, that's going to be an important thing. If you want more information on that, I highly recommend there's a blog on the internet, Energy Vanguard. The gentleman's Allison Bayless. He's a Herzerator out of Georgia, but you can gain a tremendous amount of knowledge on building science, because that is what we all do as our living, right, Dave? We have to deal with the envelope and then we have to condition it. So we always get some wacky information. Heat loss calculations, cooling calculations could be skewed. So it's really upon us, as we're responsible for gathering the best information we can so we can design these systems properly. That's going to be a pretty big industry change, in my humble opinion, that we're all going to have to start paying attention to. Okay? A couple of cool questions, Dave, that have come in. You want?
Yes, I want to address this one because I get this question a lot on a few things. Can you toss me the mic real quick?
I can't hear Rob at all.
Here you go.
Hey, Dave, you hear me now?
Oh, there we go. Yes.
Hey, what's up, buddy? So I get this question across multiple of our products. So a lot of times when it comes to like more commercial applications, we get questions regarding BMS systems, building management systems like Modbus or BACnet. Do we have any capabilities to connect to those, or would we have to get some sort of like third-party communication device for those?
Correct, right. We are doing a Modbus communication between the indoor and the outdoor, but there's no way for us to tie into any other systems out there. So yes, you would have to have temperature sensors and relays yourself put into the unit if you wanted Modbus communication to the building management system. Correct. Yeah. So we don't have any terminals for you to tie into. Correct.
And Dave, just something to throw out there, maybe not everybody's aware of it, maybe this is more reassuring to people, but air to water type of system, water can carry more BTUs than air, correct?
Yes, that's correct. It's boy, I was just talking about this the other day and I can't remember the number in my head, but it's something like 1,700 times, more capable of carrying BTUs. The way I like to compare it, this number I keep in my head, 3/4 inch copper pipe will carry the same amount of BTUs as an 8 by 14 inch ductwork, right? So the water being so dense that it can actually hold on to that. And that's the beauty behind hydronics. That's why we like using hydronics, is because of that capability. Very easy to take 3/4 inch pipe and fish it around the house compared to an 8 by 14 inch ductwork, right? So
Right.
Get a lot of flexibility with that.
Right. So, because I know there's a lot of people that are on here today, and they're gonna ask a lot of these questions going forward. They're gonna ask a lot of these questions next week when we're talking about radiant heat systems, melding these type of air to water type products to low temperature input but high output type of heating systems. They're all going to be curious about that, and I just wanted to throw that out there. That's all.
Excellent.
I wanted to throw it out there.
Let me go through a couple of the slides real fast as we are rounding out our time here. So what we want to take a look at when you are designing your hydronic system, all right, for example, that 12-degree design, we can get a maximum output of about 130 degrees. All right, we can bump the unit up to say 140, but I prefer to design your hydronic system around 125, all right, as a maximum. Doesn't mean it has to be a target, all right, especially if we're looking at radiant floors, all right, radiant panel heating. We can easily use, 105 degrees, 100-degree water to heat a lot of homes. That's how my house is done, all right? My house is a radiant slab, and the maximum water temperature I get out to my house is 105 degrees, all right? And it usually it modulates between 90 and 105 going out to my house. So, no, I don't have a System M installed.
Not yet.
I haven't, my boiler's working just fine at the moment, and it's the middle of the winter. So one thing you don't do on a system that works is change it. So, but I could put it in my home. It would actually heat well because I just re-insulated the entire home, and tightened everything up, so I could get it. So the electric element, one of the things in the buffer tank itself is that we can, when you see this slope on that square there, for example, that I can't get out of as we start getting colder outside, I can't get as much temperature out of the heat pump anymore. The electric element kind of squares off that box so we can get that elevated temperature if need be on those design days, right? So, but if we were, say, at 100 or 105 degree design, and as long as the buffer tank was getting the temperature it needed, again, it keeps the electric element off. All right, so it's got that smarts built in to control water temperature also. Cooling wise, we're getting quite a bit out of it, right? Very large amount. So we're looking at almost 4 tons. All right, at 88 degrees, I think this is where we're at, Jimmy, right? 88 degree outside design temperature, you're getting just over 3 tons of cooling out of the house. So a large amount of cooling that you can get for a lot of projects here. All right.
Yeah, our gold standard on the cooling.
What's that?
Our gold standard on the cooling really kind of is that 95 mark outside.
95 is designed for New Jersey?
Yeah.
I don't remember the cooling design numbers, right? So we look at 95 degrees. Let's pull that and crank that up to here. And yeah, we're right there at 3 ton, right? 3 ton at 95 degrees outside. So I don't remember where I came up with the 88 degrees. That might have, I know where 88 is. 88's Rhode Island. Rhode Island is 88 degree design. And water temperature can also be modulating in the cooling mode. All right. So, and everything that the heat pump is doing with the indoor unit and the outdoor unit, we're always looking at delta T's. We're always looking at temperature differences. What's the target temperature to the tank? What's the return coming back? What's the differential that we see there? And then also, what is the differential at the heat pump itself? So water coming back to the heat pump and leaving the heat pump, we're looking at everything in between and modulating as much as possible. We're modulating based upon outside air temperature with the outdoor temperature sensor. We're looking at the return coming back from the heating and cooling system. We're looking at the temperatures coming out and back to the heat pump itself, and modulate everything. So, because if it can be modulated, it's going to save energy, right? That's the important part, whether it's going to be a BTU or whether it's going to be those KWs that we're looking at, right? So let's keep that modulation everywhere. Very rarely do we see this thing running full out, full tilt, 100% compressor running outside, 100% fan, and 100% electrical element going on. So very rarely do we see all that happening at one time. Setup and commissioning, is not going to be as complicated it is as to fly a plane nowadays, right? Actually, the planes are getting less and less complicated. Just let the computer do it, right? It's just a controlled crash. That's all we're doing, right? As we hit the ground.
Thanks.
And if anybody online with us is scared of flying and I just freaked you out even more, I'm sorry about that, right? It really comes down to the heat pump interface. All right, the heat pump interface. The touch screen that's on the hydro box can also be simulated onto your device, all right, which is now online or local via the Bluetooth communication between the hydro box and your tablet or whatever, or you're going to be remotely located and you can change some settings remotely. All right. Now the remote access is for the installer. There are 2 different modes to enter in for the actual touch panel itself and the online version. You do have an installer mode and there is also a homeowner mode. All right. And the homeowner modes don't necessarily get to change settings and parameters unless we, let them, unless they are, that knowledgeable. And a lot of homeowners are. A lot of homeowners that do have a System M or any type of air to water heat pump like this is more knowledgeable than, say, the average bear. All right, when it comes to their heating equipment. So it's a touch panel. All right, it's a nice glass touch screen that we can program the system, change some parameters and things like that. So basically the installer pattern, right? You do the an I and then we log in, right? Gives a password. You can change the password. The default obviously is System M, right? And then we get into the home screen where we can find out everything that's happening within the entire system itself. You do have some of your settings, which means your, do you want it in Celsius and Fahrenheit? What is the Wi-Fi, wireless network you're communicating to, things like that. Over here is just your analytics, and you can see what's going on. Here's your home page, and then here's the toolbox that's available to the contractors to get into settings wise. Okay. So very simple setup here, and I'm going to try and launch our simulator that we have online. So let me pop that up real fast. I want to make sure that you all can see my, nope, and advance. Let's see here, proceed. And no, I didn't think the hotel was going to let me through. So I can't communicate to it. Oh, I apologize for that. So it is a very simple software to program, to set up. We have what we call the easy on, which means it just asks for a couple of questions about the system, and you can program it in about 3 minutes, and that you're doing even dawdling doing it. All right, you can have it up and running, and then you can do the fine tuning and setting up alerts and alarms and things like that going to the contractor itself. So, all righty, that's all I got there, Sunshine.
Dave, fabulous, man, fabulous. I have to say to everybody who's on, thank you for these questions. They've been absolutely awesome, and there's a lot of interest in this. So there's more education to come when it comes to these type of systems. Dave and I have discussed this numerous times. You know, I'm like, Dave, you know, majority of my territory is retrofit. You know, there's not a lot of land left, so we're not, you know, building new buildings. And if we are, they're multifamily. You know, what are we looking at here? So, you know, it's going to take some work and some building science knowledge and some real hard preparation to make sure we're going to pick the proper system for the job. This is one of your options. I mean, we have talked about in our other series, air to air. I think a lot of people are familiar with air to air, but air to water is very, very viable. We just have to make sure that we're, you know, doing our homework up front. We've got I believe, Dave, there is a project in Brooklyn, correct? That's been running.
One of our beta sites that we installed. Yep, it was during the testing phases. We installed just when COVID kicked in, man, and I didn't get to see it myself. But we, you know, like I said, we've got about a dozen projects that we've installed just for testing purposes over the last 5 years. That's when we really start, you know, like I said, we started talking about this 10 years ago, and we've been beta testing for the last 5 years. So, you know, I mentioned those three up in Toronto, Vermont, and Connecticut. We have the one in Brooklyn. There's another one in Portland, Oregon. I've got one down in Florida, down in Cape Coral area. I think there's one more in Oklahoma, I think. So I haven't been to that job site. I've been to a couple, and you know, there's no reason why you can't have one. You know, the only reason why is you don't have the right envelope for it. So, and most of these projects, they're all new construction, and they've designed the home around a heat pump, more or less. So, you know, what I've also experienced, I've got a couple going on right now in Massachusetts. And in Massachusetts, there's rebates available, and they have a rebate on a air to water, I mean a heat pump water heater, right? There's and I believe you guys have one also, correct? Right?
New York's got very aggressive program in that regard. New Jersey's always like behind the scale.
So for example, they're not. So our System M is going into the home to do the heating and cooling, but not doing the DHW because they can put in a heat pump water heater for practically free for the rebates that are going on, right? So it is a growing market. It is growing quickly, and I'm sure everybody that's online with us today, you know, is interested heavily into that too. You know, and also offering alternatives to your customers out there. But you know, you design your projects around this now, and we need our homes to be tighter and designed properly, and those low energy homes. I'm not saying necessarily net zero, but just high performance is what you like, not high end. And I think a lot of people get those two confused. When you start hearing high end, a high end home is that 15,000 square foot McMansion, you know, where only 2 people live in it. But yes, they want to be energy efficient. Well, how do you be energy efficient in a 15,000 square foot home? right? You're energy efficient in a 4,000 square foot home, not 15,000. Okay. So there's a difference between high end and high efficiency. And we really want to focus on the high efficiency projects
Right.
when it comes to that.
Just,
So, but with that being said, I'm working on another project right now in Philadelphia where we actually will have 2 units installed. All right. So the heat loss of the house itself was large, but we're doing 2 different units. We're doing one for the east wing and one for the west wing, so to speak, of the project itself, because it was a larger home, but also a high efficient home too. So, so we ended up putting 2 units in there. So we're working on those designs right now and finalizing the piping and scenario. So excellent.
yeah. Just my own opinion. It doesn't take a lot to really tighten up an envelope. For Mr. and Mrs. Smith, that could just be some basic window changes. If they ever decide to side the home, that's Tyvek wrap, which I did in my home, which made a tremendous difference. Dave, you alluded to earlier about, the fudge that's in heat loss calculations. I believe, and Rich McGrath, a friend of ours, turned me on to Nate Adams. Was he the Hydronic 2.0 guys?
HVAC 2.0, correct. Yep.
Yeah.
Yep.
HVAC, yeah. He basically has got enough data to prove that really from St. Louis to east, if you're a 2,000 or 2,500 square foot home, you're only talking 45,000 to 50,000 BTUs. So we got to tighten up our numbers. We got to be smart. Again, we're not just pulling out boilers and throwing this equipment in. But one thing to think about, if you are a plumbing and heating contractor, this gets you now into the cooling world with no refrigerant license necessary. You could hook this up. We're the space pack guys. You could hook this up to our air distribution system with that hydronic coil. Now you're giving heat. Now you're giving cool, and you can give domestic hot water in one system. That's a nice day. That's a nice profitable job. So there are. I think there's a lot of opportunity, a lot of limitless opportunity if we're exploring where to use these products properly. So it's just, today I wouldn't call this a speed day because Dave, you gave a lot of great information. And again, the questions that came in were fabulous. Great questions. And, we're going to continue to educate everybody on these type of systems because like we said earlier, our president, whether you like him or not, mentioned the word heat pump. And you guys are blessed to be in one of the most sexiest industries to be in right now because we're going to be extremely important going forward when it comes to lowering the fossil fuel mandate out there. So, this is really important. More education to come. If you're not signed up for TACO After Dark, I highly recommend you do that. They start their System M series tonight. So if you want to tune in tonight to get some more information, I'm going to be on tonight. Please do, because Johnny B and Dave and Rick Mayo are some of the best educators out there for our industry. Please take advantage.
So yeah, we are starting our winter series of our TACO After Dark sessions, and TACO After Dark is we have 2 sessions tonight. We're doing 7 p.m. and we're also doing a 10 p.m. I believe, and that's mostly for our West Coast counterparts in different time zones. And TACO After Dark obviously was something that was born during COVID, where we were able to take care of the contractors that were out there working during the day, keeping the heat on, so we can still do training classes. So it started off as our factory training class, where my job at TACO is to amass groups of people together in one room and talk for a couple of days and hang out. And when COVID said, no, you can't do that. You can't put groups of people together any longer. So we introduced TACO After Dark, and we took our factory class and broke it down into 10 one-hour sessions. So the winter session now is not our factory class, but it is going to be a detailed System M project. All right, we're going to go into detail for 4 weeks. All right, going from what the heat pump is, what we can see on the inside in a slower detail than today. Then we will get into designing and using your heat emitters for low temperature design. So we will get into the air handlers, and we will get into panel radiators and radiant floor heating. and all the way to more detailed piping diagrams compared to what I showed today, and wiring diagrams too, for your mechanics. So that's our next 4 weeks that are going to go on with the System M Take Off the Dark Winter Series. So
Fabulous.
hit the website, take a look at the training tab, and you can log in, you can register there for the classes, as well as continually coming to the Wales Darby classes, right? So you guys are doing something next week, also next Wednesday. So,
Next Wednesday, the next series will be Radiant Heat. You get to see my ugly mug again. We'll be talking Radiant Heat. We're going to be tying in a lot of the building science that we've kind of been alluding to today, since these are low temperature type of systems. A radiant heat system is a low temperature system. So, you know, please look at this as an investment in your education going forward. That's how we view these webinars. You know, yeah, we're a sales company. Dave works for a company that manufactures, and they got to sell product. We all got to make a living. But really, we put a lot of effort into education here to make sure that we are preparing you guys for all the changes in the industry and, you know, future jobs. So, you know, you can be profitable and grow your company. You're looking at me. What's up? Nothing?
Nothing, no.
All right.
Just answering a couple of things here.
All right. So, yeah, please, you know, stay in touch with us if you got an opportunity. I saw a question about, you know, where can I go for design help? Reach out to us, because I'm reaching out to Dave when it comes to that, because I need to get educated also on these as we get more and more involved with this type of stuff. So, you know, I really appreciate everybody coming on today. Again, next week, we're going to be going into radiant heat, and I'll be talking about building envelope stuff that we have to be aware of. So, Dave, I can't thank you enough. You're always there for me, and you're just tremendous, man. Thanks very much today. Appreciate it.
thanks for having me. Thanks for setting this up and working on it. And thanks for those that sat through the couple of minutes as we went through audio issues and stuff like that in the beginning. So greatly appreciate you all hanging out with us still.
Well, that was fun.
Thank you guys for having me on this morning. Greatly appreciate it.
All right, guys. So tune in next week and tune in tonight. Go After Dark.
See you then.
Thank you very much.
Thank you all.
Thanks, guys.
Enjoy.
Bye.
You